No worries. No worries. Whoever said that. Anyway, so our unit is on electricity, right? We're going to be talking about electricity this unit, which is what six is, right? To actually understand what electricity is, we need to talk about atoms, and we need to understand what electrons are. Now, I'm sure you guys have talked about atoms in chemistry class in middle school. In middle school, you were introduced to atoms. You guys didn't really go too far into it, but you were introduced to atoms in I'm not elementary school, in middle school. In middle school, I'm sorry. But yeah, you're introduced to it in middle school. But today we're gonna talk more about it, okay? And I want to intro it with this video. That's what I'm gonna intro it with.
The nucleus is very small compared to the rest of the atom. If an atom were the size of this cathedral, its nucleus would be the size of that mote of dust.
So basically, right, if you were to imagine the church as an atom, you would, well, this speck of dust right here, I'm not sure if you guys can see it. It's right here, right? Right over here. I mean, I'm literally drawing over it, but it's actually pretty small. Right, it's right there. If you imagine the nucleus, this would be it, right? So the atom would be the church, and then the size of its nucleus would be that right there. That's how small it is.
An atom is mostly empty space. To understand the nature of matter, we have to go deeper still to a place 100,000 times smaller than the atom, its nucleus. The simplest and most plentiful atom in the cosmos is hydrogen. Its nucleus is a single proton, which makes hydrogen element number 1. The clouds that surround it are the realms where this atom's lone electron is permitted to roam. What happens when you have a nucleus with 2 protons? Protons repel each other. In order to hold them together in a nucleus, you need other particles called neutrons. Their job is to keep the protons from getting out of line. They overwhelm the protons with their strong, attractive nuclear force. A nucleus with 2 protons is element number 2, otherwise known as helium. A nucleus with 6 protons is element number 6, which is carbon, the fundamental building block of life. The nucleus of a gold atom has 79 protons. They attract 79 electrons and clouds around it. The way light interacts with those electrons is what makes gold glitter. Every additional proton in the nucleus requires enough neutrons to bind them together. Up to a point. There's an upper limit to the number of neutrons you can stuff into a nucleus before it becomes unstable.
All right. So that's that, right? So now you kind of know like how atoms work, how large they are, right? So there's a nucleus, and the nucleus of the atom, you're gonna find the protons and the neutrons, and in the space around that nucleus, you're gonna find the electron cloud, which all electrons you can find in. You can find electrons in the electron cloud. So I styled this as the kind of notes I would give my students last year, right? By no means are you required to use this document. You don't have to use it at all. You can just ignore it. But I just added it there just to help guide you guys, right? And so this is basic note taking. That's how I helped my students take notes last year. So we're going to call protons and electrons elementary charges. That's what we're going to call them. Right? We're going to call protons and electrons elementary charges. They are the basic charges. All right. And now the second thing is, well, on the first page of your reference table, one elementary charge is labeled as the letter what? So what is it labeled as? So on your reference table, where is it? On the first page, right? The first page right here, and it's on your reference table. Very first, I'm sorry. The very first page. One, right here. One elementary charge is equal to 1.6 times 10 to the negative 19 coulombs. Right? So that's what you would write. So labeled as the letter E, right? That's the letter. And one elementary charge has an electric charge of 1.6 times 10 to the negative 19 coulombs. Now you might be wondering, now we measure electric charge in coulombs. Just like how you would measure a force in newtons, you measure electric charge in coulombs. And just like how newtons was named after a person, coulombs was also named as a person. And just like how Newton has laws, Coulomb also has laws, right? Except for electricity, that is. So electric charge is that. I would argue that electricity is way more important than. Actually, no, Newton is basically the fundamentals. Yeah, no, yeah. I'm wrong. Anyway, now we go back to the first page. An electric charge of 1 coulomb is what? So 1 coulomb of electric charge right here there are 6.25 times 10 to the 18. So there are that many elementary charges. There are this many elementary charges in a 1 coulomb of charge. Guys, think about how small this is, right? 1 elementary charge is a proton or electron. Basically, you're saying that one proton or electron, 1e, right? Because that's basically what it is. That's how we denote it. Has a charge of 1.6 times 10 to the negative 19 coulombs. That's insanely small. And in 1 coulomb of charge, right? 1 coulomb of charge, you have 6.25 times 10 to the 18 protons or electrons in 1 coulomb of charge. Think about how large that is. That's basically, it's 18 zeros. So there are basically this many protons or electrons in 1 coulomb of electric charge. That's how big that is. Okay, that's how much there is in 1 coulomb. So we're working on things that are like extremely small, like on a really small scale. We're working with these things right here. So 1 proton, and I'm sure maybe you've learned this in middle school or chemistry, you've learned that protons are positively charged and you've learned that electrons are negatively charged, right? So if a proton is positively charged, and we know that the elementary charge of electric charge is 1.6 times 10 to the negative 18 coulombs, then 1 proton will have a charge of positive 1.6 times 10 to the negative 18. And 1 electron will have a charge of negative 1.6 times 10 to the 18 coulombs. And again, protons and electrons, we call them elementary charges. If one elementary charge has an electric charge of 1.6 times 10 to the negative 18 coulombs, well, then the proton will just be the positive and the electron will just be the negative version. Are there any questions about the notes or concepts? I did say that I was going to be focusing more on concepts. All right, no questions. All right, cool. I'm going to be using any one of these. There are 4 polls in this lesson. I'm going to be using any one of them to you for your attendance. No, it's not possible for it to spin out. There are ways to emit a proton or a neutron. There are ways, but they don't just spin out just for no reason, right? There are going to be they can. An electron or a neutron or a proton can be lost, but they don't just spin out. And no worries. But it is 1.6. The charge of one elementary charge, we talked about this already. The charge of one elementary charge is that. That's 1e. And one elementary charge has a charge of 1.6 times 10 to the negative 19 coulombs. 1 coulomb has 6.25 times 10 to the 18 elementary charges. Anyway. Second part, I think the image, let's look at the image because I think the image is pretty self-explanatory. If you have 6 protons and you have 6 electrons, you are neutrally charged. If you have 5 protons and 6 electrons, well, you have 1 more electron than proton. Well, then that means you're negatively charged. And if you have 1 more proton than electron right here, if you have more protons than electrons, you're positively charged. Are there any questions about that? I think the image is pretty self-explanatory though. But let me know if like you have any questions about anything that you've seen so far. All right. Also, let's answer number 2. If an object has more of one than the other, we say that it has excess elementary charges, right? It has more of one charge than the other. That's what we mean. That's what we say. If you have more protons than electrons, we say that this atom has excess elementary charges, right? That's what we say it has. If it has one more electron than proton, we say that it has one excess elementary charge. It's like a one size fits all. It's like a one size fits all, basically. What do you mean? Does it change the way it functions? Yeah, if you have different protons, you're basically a different element, right? If you have so if you have more or less protons, you're basically changing the elements. If you have more electrons, you're changing how the atom functions. It's an ion. You call that an ion. You call that an ion, right? That's what we would call it. But basically, think about it, because like a hydrogen atom has one proton, and a helium atom has two protons, and a carbon atom has 6 protons. All right. Let's answer this, guys. It's a poll. I can use any one of these polls as your attendance. All right. Bugging out.
Can I get the link?
Yeah, I linked it. Can someone link him for me? Actually, I'll do it. I'll type it. You hate chem, then you hate physics, because chemistry is basically physics. All right, let's see the answers. Yeah, it's positively charged, guys. You have one more proton than electron. You have one more proton than electron, which means you are positively charged. Let's clear this. Actually. Well, there's one, guys. There is one too.
Says locked.
It's locked. That sucks. All right, it's not locked anymore.
Never mind, it's good. No, it's good.
Yeah, no, I fixed it. Sure, Samantha, no worries. Let's see the results. Yeah, that's correct. You have one more electron than proton, which means you're negatively charged. There's no way you're positively charged if you have less protons than electrons, right? All right, move on. So this one. So one elementary charge, right? So one elementary charge has a charge of 1.6 times 10 to the negative 19 coulombs. What's the charge of two elementary charges? What would that be?
3.2 times 10 to the negative 19.
How'd you get it?
Multiply 1.6.
By?
It's double.
Yeah, it's double. It's essentially double, right? Because if one elementary charge is 1.6 times 10 to the negative 19, well, then if we have two of them, well, you just double it. You just multiply by 2, right? 1.6 times 2. Then you get 3.2. What's negative 3e? What's that? How many coulombs of electric charge are there in negative 3 elementary charges?
Negative 4.8
Negative 4.8. How'd you get that?
times negative 3.
Yes. Basically, all you're doing here is multiplying by negative 3. Now, is this 3 protons or 3 electrons? Negative 3e. Because that's very important. Yeah, it's electrons. How do you know? Negative 3e, there are 3 electrons here. How do you know that negative 3e means electrons? It means you have 3 electrons. Guys,
The
please
charge
tell
of an
me.
electron is negative.
Thank God. Yes. You know that this is electrons because you see the negative sign there. 1e means 1 proton. This is 1 proton. 2e means you have 2 protons. Negative 3e means you have 3 electrons. Now, there's nothing that makes up electrons. There are things that make up protons, but we'll leave that when we get to modern physics, which is in 2 units. That deals with modern physics. That's something that we've only been researching these past 100 years. But electrons are, nothing makes up an electron. An electron is an electron. Nothing makes up an electron. So it is impossible for you to have half an electron, right? You can't have half an electron. That's not an electron anymore. That's just energy. So you cannot have like 1.5 electrons. This is impossible. You can't have negative 2.3 electrons. Impossible. The only possible number of electrons you can have is whole numbers, basically. You can have 1 electron, You can have 2 electrons, you can have 3 electrons, you can have 4 electrons, you can have 5 electrons. You can have 6 electrons, but you cannot have a partial amount of electrons. You cannot have a fraction of electrons. You cannot have negative 1.7 electrons. That's impossible. That is impossible. Right, so let's take a look at this. It's if someone says that you have a charge of negative 3.2 times 10 to the negative 19 coulombs, that's definitely possible because you have 2 electrons here. There are 2 electrons that have a charge of 3.2, negative 3.2. But if you see an object has a charge of negative 2.4, well, that's 1.5 electrons. That's impossible. You cannot have a charge of negative 2.4. If you divide 2.4 by negative 1.6, you get 1.5. So that's impossible. That is straight up impossible to have. Right? That's basically saying there are 1.5 humans. Right? You cannot have half a human. You'd be dead. Don't give me the explanation of, well, what if he's missing an appendage, like an arm or a leg? He's still a human. He's still himself or herself. So that's not a good rebuttal, right? You cannot have half a human. You cannot have half an electron. Last attendance poll, and then you guys can go. So, yeah. Answer this poll, guys.
So can I leave now?
I want to see the answers first, though. I want to see if everyone. I want you guys to see what the correct answer is before you leave.
I know what the correct answer is.
Well, 33% of my students last period answered it incorrectly, so I do want to wait. $20 seconds, guys. 20 seconds. Good. Right? That's pretty much impossible. You cannot have a partial amount of electrons. You can only have a whole number, right? You cannot cut an electron in half. Nothing makes up an electron. An electron is an electron, right? You can have 12 electrons. You can have 14. But you cannot have 12 and 1 and a third electrons, right? You cannot have 12.5 electrons. You cannot have 12.7 electrons. It's impossible. All right, guys. See you guys tomorrow.